Hello all, my project is crop prediction. So here I have developed an application that will help to predict the crop to cultivate based upon some factors like content of potassium, phosphorus in the soil, temperature, humidity, or soil pH, rainfall. All these factors will be calculated, and what type of crop is suitable for that particular condition has to be predicted. That is my project, and I have used a data set from Kaggle for this purpose. And I have included the machine learning algorithm SVM support vector machine to make the prediction. So here you can see I have beside that, I have also used Streamlight. Streamlight will help me to host the application. Okay, I only have few files that app.py that is meant for the application Streamlight, and this is for my SVM is my data program to train the data set and to make the prediction. Okay, for the training purpose, I have used the sklearns SVM support vector classifier or support vector machine to make the prediction. Here what I have done, I am using the dataset crop recommendation.csv from Kaggle, and here just this step is to display what are the columns in my dataset. So here you can see I have divided the dataset for training and for prediction purpose. I will be using in my data set you will be seeing this factor, and I want to predict the label is my crop type. What crop? Okay, if you check the data set, you can see here that I'm having this label, and this label is a rice or what type of crop is suitable for that particular land or particular soil condition. So going back here, I have divided my data set into the ratio of 80-20. 20% will be used for a prediction and 80 will be used for training purpose. And the model here I am using SVC, support vector classifier from sklearn. So this model.fit train X, train Y. Train X and train Y contains the data for training purpose. Okay, so text and text Y contains the data for testing purpose. In this particular step, it's a machine learning step. If you can understand that it is helping us to divide the data set into different category. One is for testing and one is for training. Here you can understand this X is the input and Y is our output. So based upon this input, what output we are expecting or what output should we get? That is our intention of this particular program. So here I have checked the accuracy. Here you can see this single step will help to get the model that we can use for making prediction. Okay, here SVM underscore model.sav is our model generated after the training. So I have saved the model and I will be using this model for my prediction. Here, this step will help to make the prediction. Predict crop model.predict input data frame. This is the sample data frame, and the user will be able to give the input that will be similar to this sample. Okay, this input we will be user will be able to give in the through the interface that we are using. Here I have used Streamlight for the interface. Any other TK inter or any other interface can be used for giving the input purpose. And going further, I wanted to have some data analysis by using matplotlib, but that part I am still working on that. So I can run this program and show you what exactly will be happening. Okay, since I have um, tried this program before, this model is present. Otherwise, when we are running this svm.py program, the model will be created. To execute the program, Python's file name .py. So these are the features. I have printed it to check it, and I have given some ranking also. Then we are going to streamlit run. Here my application name is app only app.streamlit run app.py. Okay. Streamlit need to be installed. I have given the detailed instruction in GitHub. If you refer to that, you can understand how to install all those things or to know more. So hope my screen is there. You can see that the application is being hosted in the local host. So based upon here, you can see enter the ratio of nitrogen content in the soil. If I'm adding something, if you want to add it like a real value, you can refer to this also. 90, 42, 43, and the humidity, pH, rainfall, and the prediction is rice. Let's try the same data set 90, 42, 43. Okay, we need to maintain 90, 42, 43. 90, 42, 43. Then 20 point, I'm copying that. That is temperature. Then nitrogen, phosphorus, potassium, temperature, then humidity, then soil pH, and the finish it. And we are expecting the output should be rice. Okay, you can see we got the rice. That means our model is working pretty well. So that's all about my project. I'm finishing here. We can check randomly. So sometime some error may be there. Like no model is 100% only predicting correctly. Okay, thank you.